Hey folks, in this lesson we're going to talk about the different information that you can get from the standard form and the factored form of a parabola, specifically with regards to the key features of a parabola. In today's lesson we're only going to talk about four: the y-intercept, x-intercepts, axis of symmetry, and the vertex, as you can see on your screen here. Okay. As we've talked about in previous lessons, it's really easy to grab the y-intercept from your standard form of a parabola. Let me just move myself over here. Okay. If I want to take a look at my parabola, my first example, y is x minus 2 times x plus 4. And I've gone ahead and expanded that as well. So we have the factored form and the standard form. The standard form is y is x squared plus 2x minus 8. We can see, just looking at our graph here, that we have our y-intercept located at -8. And so we can go ahead and we can fill that in nice and easy. Y is equal to -8. It's also really easy to grab our x-intercepts just by, we can look here on our graph. We can also look at our equation. Our x-intercepts have to do with our factored form, and the x-intercepts are the opposite of the factored form. So instead of -2, it's +2, and instead of 4, it's -4. So we have those two things there. The purpose of today's lesson specifically is to talk about our axis of symmetry and our vertex. Let's take a look at our axis of symmetry here. We are located exactly along a line that is, let's just draw this out here. It looks something like this. Okay, it's a vertical line cutting through our vertex. Okay, and if we look at the value of that vertical line, let's just look here. Okay, that value is located at -1. Our axis of symmetry is at -1. Well, let's talk about how we can get there without actually having to draw the graph. This looks like it's about halfway between our two x-intercepts, and so let's validate that. To find the halfway point, we're going to add them together and divide by 2. So I'm going to take my 2 plus -4 divided by 2. 2 plus -4 is -2 divided by 2, which is -1. And so we have just found our axis of symmetry. We've confirmed that the axis of symmetry is exactly halfway between our two x-intercepts. And so now, from factored form of your equation, it's super easy to find your axis of symmetry because it is just located directly in the middle, exactly halfway between the two. Let's take a look at another example in order to find our vertex. So we had said that our y-intercept was located at -8, x-intercepts at 2, -4, and our axis of symmetry is located at -1. Our vertex is the lowest possible point, or the highest, depending on the shape of the parabola. And in this case, our vertex is located at -1, -9. I got that information just by looking at the graph. But if you didn't have the graph, how could you find that? Well, our vertex is located, it's at the axis of symmetry, and it is at the minimum. So all we need to do is to find the minimum. In order to find the minimum, we need to find the y value of the equation when x is equal to the axis of symmetry. I'm just going to say that again. I need to find the y value of my equation when x is equal to the axis of symmetry. So in this case, I need to find the y value of my equation when x is equal to -1. Let's go ahead and let's test that. I'm going to use my factored form of my equation because that one looks pretty easy to solve. And all I'm going to do is I'm going to substitute in my x value of -1 instead of x. So that gives me y is equal to -1 minus 2 times -1 plus 4. -1 minus 2 is -3. -1 plus 4 is +3. And notice how these are negative inverses of each other. That's always going to happen. Negative 3 times 3 is negative 9, and negative 9 is our minimum. It is our lowest point of our parabola, and negative 9 is exactly where we can pull in here to find the y value of our vertex. Okay, so that's basically it. In order to find the y-intercept matches up with the c value on standard form. The x-intercepts match up with the factored form. You find the axis of symmetry by finding the midway points between your two x-intercepts. And finally, you can find the axis of symmetry just by plugging in you can find your vertex by plugging in the axis of symmetry into your equation and going from there. Let's look at a second example. Here we have y is equal to 2x minus 6 times x plus 1. The standard form is y is equal to 2x squared minus 4x minus 6. You can see the parabola to the right here. Okay, we are once again tasked with finding the y-intercept, x-intercepts, axis of symmetry, and the vertex. Okay, as we said before, looking for the y-intercept is the easiest part because it just matches with the c value on our standard form. Our y-intercept is at negative 6. Our x-intercepts are the inverses when we're looking at our factored form. It happens when we set those equal to 0. So I have x plus 1 is equal to 0, giving me x is negative 1 as my first x-intercept. And my second x-intercept, 2x minus 6, is equal to 0. 2x is then equal to 6, and therefore x is equal to 3. So my second x-intercept is going to be equal to 3. In order to find our axis of symmetry, we need to find the halfway points between our two x-intercepts. We need to add them together and then divide by 2. Let's go ahead and do that. I need to have negative 1 plus 3 divided by 2. This is giving me the axis of symmetry. Negative 1 plus 3 is equal to 2, all divided by 2, which is equal to 1. And we can see that that lines up on our graph here of being our axis of symmetry located at the number 1. So our axis of symmetry is at 1. Finally, in order to find our vertex, we need to find the y value of the parabola when x is equal to the axis of symmetry. So I need to plug in my axis of symmetry value into one of my equations. And in this case, I'm going to do the standard form of the equation because why not? 2 times 1 squared minus 4 times 1 minus 6. Okay, again, I'm substituting in that axis of symmetry value in for my x. 1 squared is just 1, 2 times 1 is 2, negative 4 times 1 is negative 4, and then I have a negative 6 left over. 2 minus 4 minus 6 is negative 8. We can see that matches up with our minimum along our graph there. And so our vertex is going to be located at 1, negative 8. Okay? And that's it. So starting from factored form, you can expand to standard form, or you could go vice versa, and you could go from standard to factored. Either way, you will need both. You find your y-intercept and your x-intercepts right off the bat just by looking at your equations. And then from there, from the factored form, you use that information to find your axis symmetry halfway between the 2 points. And finally, to find the vertex, okay, by substituting in the value of the axis symmetry into your equation. And that's it, folks. Great job.